All right, hello people watching this video. We're going to get about halfway through 10.2. This is the first section that we do in chapter 10. We do 10.2 and then we do 10.1, but we'll only get about half of this done today, and then tomorrow we'll do the rest of it. 10.2 is the law of sines, which we do in algebra or in geometry. We do the law of sines in geometry, but there is one little weird thing that happens with the law of sines, because sometimes you don't have a solution, or sometimes you have two solutions. So if you don't have a solution or you have two solutions, we'll talk about when that happens, okay? So you need to have your calculator in degrees for this section, because all of these measurements that we do for sines is going to be in degree measures, okay? So make sure your calculator's in degrees, otherwise you'll get the wrong answer. All right, so law of sines. This is for non-right triangles. The law of sines and the law of cosines. Now, if it is a right triangle, for right triangles, what do you use? If it is a right triangle, what do you use? What do you use if it is a right triangle? If you have a right triangle and you're trying to solve for things, like let's say I have, you could use the Pythagorean theorem. So like let's say I have that this is 37 degrees and I want x and I have like 14 right here. How would I solve for x? If I know two of the other sides, I could do the Pythagorean theorem, right? But what would I do to like solve this thing?
This is over here. I need to go to
14 times.
What?
No. Yeah, 14 times the sine.
Okay, so what process are you using? SOHCAHTOA, right? So you can use SOHCAHTOA, and I'm going to say or the Pythagorean theorem, if that's the information that you're given. So SOHCAHTOA or the Pythagorean theorem for a right triangle. But when you don't have a right triangle, you can't use any of those options. You have to use the law of sines or the law of cosines, which is what we're going to do in 10.1, which is like Friday or Monday or whatever day we do that, okay? All right, so the law of sines, this is the equation for the law of sines. It is sine of A over A equals sine of B over B, okay? Sine A over A, sine B over B. Also sine C over C, but you'll only ever set two of them equal to each other. So it doesn't really matter what angle you're dealing with, just as long as, you know, like you set two of them equal to and make a proportion. Capital letters represent the what? Angles. Lowercase letters are the sides, okay? Now, you can, a lot of textbooks teach it this way, A over sine A equals B over sine B. It does not matter which one, or sine B. It doesn't matter if you put the sides on the top and then the angles on the bottom. It doesn't matter. Okay?
Are you recording?
So, yes, I am. So it doesn't matter, like if you flip them around, that's okay. If you can't remember which one goes on top and bottom, it doesn't really matter. Like as long as you do the same thing for each one, okay? All right, now, the important thing is when you are doing the law of sines is that you have two sides and two angles involved, okay? One of those things you're solving for, okay? So two sides and two angles. Like here, I have two angles and two sides, right? Okay, and I'm solving for one of those things, right? All right, I don't have the right angles. We're going to fix that here in a second. But two sides, two angles, that's what it involves. When we do the law of cosines in section 10.1, we have three sides and one angle. So that's how you can determine whether it's sines or cosines, okay? So this one's going to be the law of sines. We're going to solve for this one right here. Here we go. It says find the other angle measures and side lengths. A lot of times they'll say solve the triangle. That means find everything that's not already there, okay? And the strategy that I use is I just list out capital A, capital B, capital C, lowercase a, lowercase b, lowercase c, and then it's easier for me to see what I have and what I need, okay?
If you have a triangle, doesn't all the angles add up to be?
Yes, they do. True. Yes. So that's that. She's already like on to the first thing. Capital B is 20 degrees. Capital C is 31 degrees. I'm just looking off of the thing, or up here. And capital B is 210. Now, how do you know where capital B lives? Or excuse me, lowercase b lives?
He's the opposite.
It's opposite from angle B, right? Okay, so angle B is over there, so lowercase b is there, right? That's how he works. Okay, now, I know that I can use the law of sines when I have an angle and a side of the same that I know, right? That's the only time I can use the law of sines, is if I have an angle and a side that I already know, okay? So we're going to use that, And then we're gonna use this C value and we're gonna do this grouping and this grouping, okay? So I'm gonna set it up sine of, let's say 20 over 210. Okay, the sine of the angle over the side equals, and I have sine of 31 over C. Okay, then I'm gonna cross multiply. So you're multiplying and then multiplying. So I have 210 times sine of 31 equals C times sine of 20. Yeah, that's my cross multiply. Okay, now if I'm trying to get C by itself, I'm gonna get rid of the sine 20 by dividing by sine 20. So you can type in that stuff. 210 times sine of 31 over sine 20. Practice typing that in and see what you get. And see what you get for little c. Little c. What should little c be in relationship to 210? Bigger or smaller? You know?
Bigger.
Bigger because the angle's bigger, right? Capital C is bigger. Okay. All right. What'd you get for little c? Anybody? 316.23. So we'll go one decimal place on everything. 316.2 is what C is. Okay?
Did I do that right, Lunch?
I did not get that.
No,
I did.
she didn't get that. What?
I did.
You did?
Yes.
You got 316.2?
Teachers, please dismiss the
There we
FFA
are.
students going.
That's what I got
today.
today.
316.2. Okay, if you didn't get that, your calculator might be in the wrong setting or you're typing something in
Oh,
wrong.
now I do. I don't know what it is.
You did? You got it now? Okay, perfect. I want to make sure you know how to get it. Okay, now what are we going to solve for next? We have two more things.
Big A.
Can we do big A? How do you do big A?
The other.
These all have to add up to be 180, so keep that in mind. These add up to be 180. If you add those two, that's 51, and subtract from 180, that's like 129. Is that true? Yeah, 129. Okay, now we can do the law of sines again. All right, and you can use the 316.2 if you want to. You can use that grouping, but I'm going to use this one because the 316.2 is rounded, right? We want to try to avoid the ones that we rounded. Okay, so sine of 20 over 210 again equals, we've got sine of 129 over A. Now, I'm going to try to do this without writing everything out because I'm lazy. I'm super lazy. So if we're solving for A is right here. We're going to cross multiply these and we're going to divide by this guy, right? So I'm not going to write out like the 2 equals, right? That times that divided by sine of 20, and Libby got 477.2. Yes, 477.2. Now, does that seem reasonable? 477 is a huge number,
But it's also the
But
biggest.
it's
but it's also the biggest
also
angle. Okay, so I would always kind of check that to make sure, right? Make sense? Okay, good. That's the law of sines. All right, there is one more little thing. When you're solving for an angle, you have to use the inverse sign, and we'll get to that point, okay? But let's talk about this. If you guys have your homework assignment handy, I don't know if you can see that. Homework assignment handy. Number 5, 6, 7, and 8 ask for how many triangles will there be? Most of the time you'll only have one solution, like the last example that we had. There's only one triangle that can be made out of those, but sometimes like the sides literally are too small and they don't fit together. Or sometimes you'll have an angle, like a triangle that could be made from two, you could make two different triangles. So we'll talk about that. So that's what they're asking for 5, 6, 7, and 8. This is the part that we're starting now, okay? And it has to do with this chart. This is like your flow chart, okay? This is your flow chart of how things are gonna go. So we could have the scenario where there's no solutions. And take a look at this. We have one side here, we have another side here, and then we have another side here. And the way that this works is that our third side is not long enough to touch down to the opposite one, right? Like sometimes they'll give you side lengths that are not long enough, okay? And that will happen when you have your side A and it is less than side B times sine of A, right? Like that's how that works, okay? So when you have that happen, keep that in mind. This is the thing that you look for, and then that will give us no solutions. We'll go through these, okay? If A is equal to B sine of A, then you will have one solution, like what we just got done doing. We had one solution. He came out nicely. We've solved all 6 things, and he was good to go. If A is greater than B sine of A, you'll have 2 solutions, okay? So if we look at our 3 sides, we have like this guy going on here, right? But then they've taken this third side and they're like, we can swing that third side over here and make a triangle out of him that way also, right? So like that side can swing back and forth, and then I would have two triangles. I would have one that looks like this, whoop, and then I would have one that looks like this, right? Like those are the two options that I have, okay? So you are not going to have to solve the two triangles, right? You're just gonna have to tell me like there would be two. So that's how that works, right? And then there's also one solution if they give me like different things. So I'll show you how this all works. Okay. All right, here's the deal. Ready? Let's go down to, do they not give me an example? What? Okay, we're gonna use an example from your homework then. Ha. Perfect. Okay. All right, so we're gonna use an example from your homework, and it is, we'll just do number 5. How many triangles are there? So this is number 5 from your homework. The things that they give me, they say angle A is 30 degrees. They say B is 12, and they say capital A is 8, or lowercase a is 8. Okay. All right, so there's the information that it gives me. Okay, so they give me the angle A, they give me B, and they give me A. Okay. Now, real quick, if you're looking at like number 7 as well, okay, number 7, they don't give you B, they give you C actually. So they're giving you C equals 18 and A equals 5. Does it matter? No. C might as well be B. So it doesn't really matter on number 7 that they give you C instead of B. It can be swapped out for B. So just keep that in mind. That's number 7. All right. So here's the deal. We have to decide. All right. Is our A value less than B, or is our A greater than B? Oh, wait a second. First of all, first thing we have to decide. Is angle A less than 90, or is angle A greater than 90? Less than 90, right? Angle A is 30 degrees. So we're in this top box right here. We're going to cross off this one. We're not going to use that information. All right, now we have to decide, is A less than B, or is A greater than or equal to B? Or little a. Little a is less than B, little a is greater than or equal to B. Okay, less than A, or less than B. So we're looking at these 3 scenarios happening. All right, so I want to compare A and B times sine of capital A, right? So little a is 8, B is 12, and sine of A is 30, sine of 30, okay? And what is that relationship, okay? So somebody for me real quick, take 12 times sine of 30.
6.
Is 6 exactly, okay? So we have this thing happening, right? Like that's less than. So out of these 3 things, which one are we? The first one, the middle one, or the right one? The right one, right? We have this scenario where A, 8, is bigger than B sine of A, so that means this third side could have swung back and forth. So we could have 2 different triangles, and number 5, it says how many distinct triangles? There are 2. 2 different triangles that could be made by those dimensions, right? You're not going to actually have to solve all of the sides of those triangles, but there are 2 triangles that could be made by that. Does that make sense? Do you see how this flow chart works? Okay, so you'll have to come back to this to go through 5, 6, 7, 8. Got it? Okay, that is the weird case, all right? Let's do like 2-ish more, and then we'll stop, okay? All right, so example 2. Given a possible triangle, blah, blah, blah. Is this one gonna have a solution? Maybe. Don't worry about the supplemental angle identity. I'm not gonna go through that with you. Let me just check. Let's do this one. Example 2. If we know that A is 65, okay, I'm just gonna see, is there a solution for this? If we know that A is 65, okay, we are in the top box, right, where A is less than 90, okay? And if we do A, let's see, A is less than B, right? 6 is less than B, so we're looking at the top here. We're trying to see how many solutions he has, all right? So A is in what relationship to B times sine of A? Let's see, 6, and we have 7 sine of 65. Let's see. What is 7 times sine of 65?
6.3.
6.3. 6.3 is here, and 6 is here. So we have this thing going on.
So it's no solution.
Is there no solution there?
There's no solution.
You see that? No solution. So I'm glad we didn't start this problem because we would have ended up with an error probably, right? So this one is one where we'll have no solution. No solution. We'll have one of our sides not be long enough to make the third side. Got it? Okay. All right. Here we go. Example 3. Let's do this one. An airplane takes off from carrier B and flies for 12 kilometers this direction to carrier A. At that instant, an observer, blah, blah, blah. Let's see, what are we trying to do? How far is the plane from the destroyer, which is this little b? So we're solving for that little b. Okay, let's see what we've got going on here. All right, I'm just going to map out what A, B, and C are. I'm just going to list them out. A, B, C, and then little a, little b, little c. And we can see what we have, what we need. We don't have to solve for all of them, like all of the remaining things, but we might have to solve for something before we find little b, okay? So things that we know, what do we know?
A is 12.
Little a is 12.
And
No,
then
little a is not 12.
Little a is not 12.
Which one's little a?
is
Little a is
Little
5.
Little
Yes,
A is
little a is
5.
5. Which one's 12?
B. No,
No.
C.
C, little c is
Oh.
is 12. We're trying to solve for little b, okay? What else do we know?
Little C is 37.
Capital C is 37. Okay, all right. So we can't necessarily solve for little b until we know capital B, right?
Yeah. Could we do the Pythagorean theorem?
Nope, because it's not a right triangle.
We have to
Oh,
solve
yeah.
for A first.
We have to solve for capital A first, right?
Mhm.
So we have to do this with the law of signs, right? To solve for capital A. Then we can solve for capital B by adding or subtracting from 180, and then we can solve for little b. So we do have to find all three things, which is kind of a pain in the butt, but whatever. So sine of 37, this is the weird thing that could happen. Sine 37 over 12 equals sine of A over 5. All right, this is the weird thing that's going to happen. All right, so be careful of this. Yeah, I'm going to cross multiply 5 sine of 37 equals 12 sine of A, right? Okay, if I cross multiply, I do that. I'm going to divide by 12 to get sine of A by itself. All right, if you do 5 sine of 37 divided by 12, you're going to get a decimal. It's like 0 point something. Somebody type that in for me. 5 sine of 37 divided by 12.
0.25.
0.25-ish or something like that, right? But that's equal to sine of A. That's not what A is. So how do I get A then?
Inverse of sine.
You do the inverse sine of that number, right? So you guys should have like an answer button. If you can use the full decimal, that would be great.
14.5.
A is 14.5. Yeah. 14.5. So do you see how the weird thing is if you're solving for an angle, you'll eventually have to do the inverse sine of that, okay? Now we can find capital B. If you add those two together and subtract from 180, you get, I'm going to cheat off of Libby, 128.5, okay? And now we can do the law of sines again. So sine 37 over 12 equals sine of 128.5 over B. And I'm going to cheat and not write everything out. I'm going to cross multiply those and then divide by sine 37. And that should give you little b. Okay. Little b should be the biggest side. True? Because 128 is a big, big, big thing. Libby got 15.6. Everybody else get 15.6 that tried it? Sure? 15.6, what units are we in? Miles? Kilometers. So 15.6 kilometers is that one. Okay, good? All right, let's stop there. We'll stop there, okay? All right, you should be able to get through. We didn't do any area things, which is the back side of the sheet. Find the area. We'll talk about that tomorrow, finding area. But you should be able to do the first, like the whole front side. So 1 through 8, you should be able to do all of those. Now again, 5, 6, 7, 8, you're just finding how many solutions there are. Got it? Make sense? Perfect? Okay, goodbye people watching the video.